let's say you drop some object and you let it fly through the air. There's a force of gravity pulling down on the object, and then there's also a force caused by the object hitting all these air molecules. The object needs to push these air molecules out of the way, so it needs to impart some momentum on it, meaning the object's momentum has to decrease. There's also some heat created, so this can be modeled by a force moving upwards called the drag force. And you could say it's of the form b v to the p, where v is the velocity, b is something called the drag coefficient, which you can determine either by experiment or thinking about the properties of the object and the fluid it's moving through, and p has to do with something called the Reynolds number for the fluid. Now, if you do F equals ma, the forces are the force of gravity pulling down, but now I'll actually let down be the positive direction. So gravity will be positive, and then the drag force is pulling it back. So it'll be minus this. And it's equal to ma, but a is just dv dt. Now let's divide out by this m on both sides. So now we have a differential equation of the form dv dt equals to g minus b over m v to the p. So this can't be solved really easily with p, I don't think. So what can we do here? Our best choice is to analyze, try and figure out some properties of solutions to this differential equation. So first of all, notice you can throw the ball down at some initial velocity v0 and have it basically roll down constant. So basically, when the mg, the force of gravity, perfectly balances with the drag force, you can throw it at such a speed. So what is the speed? Well, we want these two forces to balance. We want the dv dt to be 0. So you want g equaling to b over m v to the p. So now we can solve for v and we get something like, let's see, g mg divided by b and then the pth root of that. So if you throw the velocity, the ball at this velocity, it's going to stay exactly the same speed. Now let's call this let's give this a name. I'll call it, let's say, mu. Okay. So now notice that if the velocity is less than mu, then the dv dt is positive, and if it's greater than mu, that means dv dt is negative. Now, this means if you throw the ball at a velocity less than mu, so if you maybe drop it so it's 0, then it's going to steadily increase in speed. But if you drop it really fast, then it's actually going to decrease. The speed's going to decrease and it's going to slow down. So now you can sort of see that actually, if you graph this velocity, if you start it off below it, it's going to slowly approach this mu. And if you start it above it, it's going to go down here. So in a sense, the limit of v, as time goes to infinity, is mu, where v is the solution to this differential equation.